Well, welcome to Build a Better .NET Core Azure service. Now there's like music coming in. I'll be your host for this session. My name is Jeffrey Richter. I'm a Microsoft software architect, and I was also the co-founder of a company called Wintellect, but most people are familiar with me from the various books that I've written over the years, and I put some of my book covers over here. My most recent book, by the way, is not actually a book. It's a video series on how to orchestrate distributed cloud applications. Nice. And this is a 6.5-hour free video series that's available, and the links are down here at the bottom. I'd strongly encourage you to check that out. It's not specific to any technology like Azure. They suggested that I tell you something personal about myself during this session, and so here's my personal thing. I have an airplane license and a helicopter license, and that's why there's avionics equipment on the book covers. So now you know something personal about me. And then there's information at the bottom left, which is how to get in touch with me if you'd like. So about a year ago, I helped form this new team at Microsoft, which is the Azure SDK team. And the charter of the team was to reimagine the Azure SDKs so that they were a better experience for software developers like you. And we are, as of today, we are shipping some of our new SDKs, which I'll get to in a moment. But we had certain core tenets or guidelines that we as a team follow, and I think it's important that you as users of these libraries understand our core tenets. The first of our core tenets is that the Azure SDKs be consistent. The way the SDKs used to work at Microsoft is that one team would build their SDKs, and another team would build their SDKs, and a third team would build their SDKs. And a lot of times the teams would not communicate with one another or look at each other's work. And so you, as a customer, would grab an SDK, learn how to do authentication with it, learn how to do I/O operations with it, and then when you grab an SDK from another team service, then you'd have to relearn it all because there was no consistency across those SDKs. So with our new team now builds the Azure SDKs, and we enforce consistency among them. So you, as a software developer, you learn how one works, and it'll be much easier for you to adopt and learn the other ones that come out. So some examples of things there is that the main types, is that me doing that? The main types that we expose in the SDKs end with the word client, like a blob client, or key vault client, keys client, for example. So when you get an SDK and you install it, the first thing you would probably look for is, in IntelliSense, is some type ending with the word client. And that's going to be your starting point. All of the methods on these clients that do I/O operations, they all return a response of T. So response is a type that we define in this library called Azure Core. And it is the base library that all the other SDKs depend upon. So when you learn how this responsive T works, it's going to work the same across all the HTTP libraries that we support. The only thing that's different, of course, will be the T, depending on the exact operation that you are performing. We make sure that all of the APIs take a cancellation token as their last parameter. That's really useful for you to build applications that are responsive because you can cancel the operation. If the service is not replying in a certain amount of time, we make sure that you have a way of canceling all these things. I think that this cancellation is critically important and is underused by a lot of developers when they're building cloud applications. So it's been a big important goal that we support this universally throughout all of our SDKs. The typical example is when somebody wants to bring down a service, maybe because you want to scale down, or maybe because you want to bring down version 1 so you can bring up version 2. A lot of times the best way to do that is to signal a cancellation token and have everything that's in flight cancel itself so you can bring down that instance of the service and then bring up a version 2 of the instance, or if you're just scaling down, scale down as quickly as possible. The other thing that we do with our .NET libraries is while .NET has adopted asynchronous programming for a lot of people, there are a lot of people who find the async await stuff to be complicated, or sometimes you're just building command line utilities and the asynchronous stuff is just getting in the way. So we have decided that with our new libraries, we offer the async methods that you would expect from .NET today, but we also offer the synchronous methods as well, to make it easier for you to build command line utilities or to quickly experiment with a service and not have to worry about all the resource conservation that you get when working with asynchronous code. The next tenet that's important to our team is that the SDKs be idiomatic for the language. One thing that Microsoft has been accused of is that our Python libraries look like they were written by a C# developer. We understand that, and we understand that that's not ideal. So our new team, we have a Python team made up of Python expert engineers, and we have a JavaScript team, and we have a Java team, and we have a .NET team. We also are doing Go and C and C++ as well. And these teams have engineers who really know that language and they know the culture of that language, and then we build the SDKs to meet the developers where they are who are working with that language. Now you as .NET developers, because that's what this talk is about, Microsoft has a lot of .NET people. And so I don't think this is that big a deal to you, but for the people working in other languages, this is a bigger deal. But more than just being idiomatic, we're also taking advantage of new language features that have been showing up in C# and .NET. So for example here, async enumerator, which is a new feature, we are leveraging that in our SDKs. And you might also see us using span of T or memory of T, which are also relatively new features in .NET, and we're going to use these in the SDKs as well. But we don't want to force you to use these things, but we will make them available for people who are more, let's say, memory conscious. That's where memory T and span of T comes in, or people who want to enumerate over things asynchronously with a nice programming model. That's where async enumerator comes in. Another thing that we have done is we have said that there are certain things that distributed applications have to take into account all the time. These are things like authentication. These are things like retrying operations. These are things like logging. And so we have built these kinds of things into the SDK using what we call our pipeline. And I have another slide where I'll go into more detail on that a little bit later on. Finally, we want to make things so that they're very easy for you to discover. It's all about you being able to write your code more easily when working with Azure services. That's really our main goal, is to make it so that you are writing less code, it's more likely to work, it's more diagnosable or debuggable when it doesn't work. That is a goal that we actually have, is to make it so that when things don't work, you have a better time of trying diagnosing it yourself without contacting Microsoft to get assistance. So we have better help, we have better documentation, we have better samples. We have one GitHub repo for all of our .NET libraries in it. Everything is open source, and we strongly want to build a community around this, and we would like you to contribute and post issues and everything else into our GitHub repo so we have a good ongoing relationship with you. By the way, I'll be allotted our booth over here during the week, but we have other people there too. So if you would like to come over and talk to us, there's like 7 of us from the team here. We would absolutely love to talk to you and learn about what your needs are and how we can make this better. All right, so with that, I just have a couple of code samples that I'm going to show you proof of some of the things that I've been saying. The first code sample here at the top, this is for an ASP.NET Core scenario. If you are using version 11 of our Blob SDK, that's the older stuff, then in order to configure it for an ASP.NET Core app, this is the number of lines of code that you would have to write. And because we only offered asynchronous APIs there, you'd have to call things like getAwait or getResult, which a lot of people don't do correctly. A lot of people just say .wait there or .result there. That's not really the right thing to do, because it won't throw the right exception, is the reason why. So we now offer synchronous methods here so that you don't have to do stuff like that and make your life easier. If you look down below, using the version 12, which is our new stuff now, you can see you can do the equivalent in this one API because we've built in better support for ASP.NET Core scenarios. Another example I want to give you is related to the consistency conversation. I told you that we have a library called Azure Core. We have another library, and all our SDKs, or client libraries, take a dependency on Azure Core. We have another library called Azure Identity. And this is an optional library that you can use, and it also depends on Azure Core, and it has all of our identity mechanisms in it. A lot of Azure services have multiple ways or different ways of authenticating with them, and one of the main pain points for customers has been, how do I authenticate in order to talk to this service? So we have done a lot of work in this area to make authentication a lot easier. And I have more to say about that also a little bit later on, but let me show you a quick example of just using it here. So here in the Azure Identity namespace, which is also in the Azure Identity DLL, there's a type called default Azure credential. We expect most customers will use this default Azure credential. It's actually a wrapper around 4 different other kinds of credentials, and it does kind of a probing mechanism to figure out which one is the best for your scenario. Again, I'll say more about that later on. On the next line of code, I'm using our new blob storage SDK, and I'm creating a blob service client. You'll notice the type ends with the word client, because that's our main types for working with a service. And the client requires a URI, which is the URI to your storage account. You would replace account with the name of your account, and then you pass in a credential. And I'm passing in that default Azure credential here. Then you'll notice I'm also using the key client, which is a client from the Key Vault service. And very similarly, it takes a URI as its first parameter, and you'd pass in the URI with your vault name for the first part of the host. And then you can pass in the same credential. So this is a unique thing you've never seen before with Azure, where a credential type can actually, a single instance of it, in fact, can be used with multiple client libraries simultaneously, right? So when you learn how that default Azure credential works, you'll now be able to use it with all of these client libraries that we ship. The next thing I'm showing you is I'm creating a cancellation token source, just to show how cancellation would work. And then on the blob service client, I'm calling a method. In this case, it's create blob container. I pass in the name of the container, and I pass in the cancellation token. Again, showing you that all our methods take a cancellation token, and this method returns a response of T. In this case, the T is a blob container client. On the next line, I'm using the Key Vault client, and I'm creating a key. You'll notice it works very similarly. You pass in the key name. This also requires a key type parameter, so I'm passing that, but it also takes the cancellation token as the last parameter, and it is returning the same response of T, where in this case, where T is a Key Vault key. Right, so again, once you learn how the storage SDK works and how to create an object, authenticate, to do an operation, cancel it, get the response, then learning how to work with Key Vault or any of the other libraries is going to be very, very simple. And you should be able to ramp up on these very quickly. I mentioned earlier that we have this library called Azure Core that all the other client libraries depend upon. To be more specific, all the other HTTP client libraries depend upon. There are some libraries like Event Hubs that doesn't use HTTP for communication, so it does not use the same Azure Core. What we did with this Azure Core is we created this thing inside it called an HTTP pipeline. And a pipeline, by definition, is an ordered set of policies. Each policy does something related to making the HTTP request or processing the HTTP response. And the pipeline is extensible. And what that means is that you could create your own policies. All you have to do is derive off of our base class, and then you can insert your policies into this pipeline, and then you have some control over the making of the HTTP requests and responses. Now, we've already created a bunch of policies that we ship by default in the library, and we have these 8 here that I mentioned on the slide, and I'll just very briefly run through them. So the first policy is a client request ID policy that whenever an HTTP request is going out over the wire, we'll insert a header into the HTTP request with a GUID for the ID. So this way there's a unique way of tracking every request and response that comes back. If something goes wrong with that, like the service returns a failure when you expect it works, you can actually get on the phone with Azure customer support and give them these ID numbers, and they can try to track down what happened on the server for you. We have a retry policy built into the pipeline. For distributed applications, I think this is absolutely mandatory, and we provide it for you for free, but you can configure it. Like, you can specify how many retries you want to allow, and you can specify what the delay is between each try. This way, if you make a request to a service and you're being throttled, we will retry the operation and make it happen again. Or whatever, it's possible that maybe a timeout will occur while making a request, and we could cancel it, and then we could retry it again. So we have a default retry policy, but again, if you don't like ours, you can pull this out and you can put your own in. Retry, by the way, is the hardest one of these to write, so you're taking on probably a multi-week project, at least, if you do that. Start with our code, it's open source. The third is authentication. When you create these credential objects and you pass them in, they get associated with our authentication policy in the pipeline. So every time a request goes out the wire, that authentication takes place, and it usually sets the authentication header in the HTTP request before it goes out. We have logging built in, so you can monitor every request and every reply that's coming back, or just the failed responses that come back. And you can hook into this logging, and you can also have other logging in your program and integrate them together to have like a unified logging experience throughout your entire app. We have a buffer response policy. This reads the payload down from the service into the client, and if while reading the payload the connection fails, the retry policy will reissue the request in order to get it. That's used for everything except when you are downloading unstructured data like blob data or file data. In that case, we can't download, let's say, a 5 terabyte blob into a buffer. We just won't do it. So this is for fixed payloads, we use that. We have extension points for distributed tracing, and you can pick whichever distributed tracing technology you want to use, like OpenCensus, for example, and plug that in. That way you can see in your application where it came in from and where it's going out to, and you can build this graph or tree of child spans and, well, parent spans and child spans to see the flow of your entire application as requests go from service to service. The transport is the final one, really, which is, it goes over an HTTP request. But you can replace this with just reading from a local cache, if the data is available locally, and if it's not available locally, then go over the wire. So you could even get involved with this if you want to. And then finally, as I've mentioned before, you can create your own policies and you can plug them in. I mentioned, I was having a conversation with somebody at the booth earlier today where said, oh, so I could create a circuit breaker policy and insert it in. Yes, absolutely you could, and that would not be that difficult a task to undertake. We may do that for you in the future someday, but we don't have that today. I mentioned authentication, and I mentioned the default Azure one. That was what I showed in my demo, and I said that that's really 4 authentications in once. When you use that, it will try to look for environment variables first, which works on any platform. Then if environment variables cannot be found, it will then try to use managed identity, which only works if your program is being hosted in an Azure service. Then we will look at the shared token cache. This allows single sign-on authentication for the developer experience. Like you can sign in with Azure with Visual Studio, and when you put your credentials there, when you run your app that uses this authentication, it will find those credentials and just use them. And then there's the interactive browser experience for the developer experience. The default Azure is these 4, but you can also use any of these 4 directly. You don't have to use it through the default. And then we have other authentication mechanisms that are available as well. And then as I said before, different Azure services authenticate different ways. So as our team tackles SDKs for other services, we will be adding some other server-specific authentications here. Like for Azure Storage, we have a shared key credential, but that only works for Azure Storage. It doesn't work for other services. And that's it. The last thing you need to know is our link to our GitHub repo for where you can find all the SDKs and all the source code for everything. Today, we're shipping the SDKs for storage, Key Vault, and identity, but we will have more SDKs coming soon, like Event Hubs, Cosmos, app config, and the management planes. Right now, we're just focused on data planes, but we will be getting to management plane. Check out our booth over here. I'll be there a lot if you want to see me. We have competitions and prizes and other ways for you to stay in touch with us. And that's it. Thank you very much for coming. Thank you.